Hello students, last class we learned about force between the two charges using Coulomb's inverse square law. So now we are going to discuss the inverse square law in terms of vector form, that means force between the two charges in terms of vector form. So here I chosen a coordinate system and here I chosen two charges, one is q1, second one is q2. Both are at different positions. According to coordinate system, I taken the vector. First one is this is position of the q1 as a r1 vector, and the second one is at a position of q2, that is r2 vector. Because according to vectors, you know that position of the charges explained by position vectors. r1, r2 are the position vectors here. Now the q1, q2 both charges separated by distance of how much? This is r. Now both are repulse each other. The force of repulsion is acting along the line joint between the two charges, as we are looking here, and there is arrow marks are given here. That is the direction of the unit vector direction. These forces are going to act. Now, what is the way the forces are acting? First, q1. On the q1, second charge is going to apply the force. That means the second charge applies the force in the first one in this direction, as you're looking here in this direction. That is called F21, force by 2 on 1. At the same time, first one also applies the force on the second one. This is the direction of that force. This is nothing but called as force on 1 by 2. So both forces are both repulsive forces are acting along the line joining between the two charges which are separated distance apart. Now, how to write the vector form of equation? First, force is the vector quantity. You know that force formula. Okay, so basic formula of vector we can write in terms of it is the product of magnitude of the vector into unit vector in that direction. So what is the unit vector in this direction? I can write as r cap, because r is the distance between them. So in the along the direction of the r, so the unit vector is equivalent. So force vector is equal to magnitude of the vector into unit vector of that one. So what is the magnitude of the vector? In this case, magnitude of the vector mod f is equal to, just previous class we done, that is 1 by 4 pi epsilon naught into two charges q1 q2 by r square is the formula for that. Already yesterday we derived this. Derivation is nothing but this one in the previous class. So here what I can do is, this is the magnitude, right? So I can write the vector form of this equation as mod f is equal to 1 by 4 pi epsilon naught as the magnitude, that is q1 q2 by r square. I can write in terms of magnitude, that is mod f, okay, into unit vector. That unit vector is nothing but r cap. So can I write the r cap in terms of vector according to basic statement of unit vector? So before that I am writing this 1 by 4 pi epsilon naught, that I can write as q1 q2 by r square into this r cap. I can write as vector r vector by magnitude of the r vector. So anyway, this r square is also magnitude, this is also magnitude. So I can write this f vector is equal to nothing but 1 by 4 pi epsilon naught into q1 q2 by r cube by in the direction of r vector. This is the vector form of representation of this force. But here two forces are we are finding in the question, that is F12, F21. So what is F12? So first F12 means force by 1 on 2. This is the F12, right? This is F12. Force on, so force by 1 on 2. That means first charge is applying the force on the second one. Force by 1 on 2 is equal to, I can write as 1 by 4 pi epsilon naught. The charges are same, q1 q2 by r square. What is r here? In this case, we have to take the difference in the length of that. That means r, okay, here 1, this is 2. So distance is always we are measuring from opposite to this. That means 2 to 1. This is the way you have to take 2 to 1 whole cube you have to take. Into the position vector also we are taking from 2 to 1. So F12 is equal to 1 by 4 pi epsilon naught q1 q2 by r2 to 1 whole cube into r2 minus r1. If you want to write more precise, this I can write as 1 by 4 pi epsilon naught, that is q1 q2 by r2 to 1. I can write as r2 minus r1, that is whole cube, into r vector. I can write as r2 vector minus r1 vector. Okay, this is the way you can represent the one of the force. Similarly, F21 also similarly I can write F21 is equal to nothing but is also I can write as 1 by 4 pi epsilon naught into, that is q1 q2 by r1 to 2 into the vector is r1 to 2 vector. in the direction of this. So this is the way you can write the vector form of representation of force between the two charges. According to, if you observe this one, both are acting the same line. So we can say here F12 is equal to becomes exactly opposite to minus F21. So both are equal in magnitude, opposite in direction. So they forms action, okay, action reaction pair along the line that line joining between the two charges. So using the vector form of representation, we can able to express this one. This methodologies we are using in solving the little bit advanced level of questions